We are going to continue to work on our 3-address code and on assembly generation. As I said, the original compiler didn't have any intermediate representation, so the assembly was generated directly from the abstract syntax tree, and to make the introduction of an additional intermediate representation easier, I just copied the assembly structure and made it to the intermediate representation to this 3-address code. So there is basically a procedure that converts 3-address code to the assembly. It is called an tele instruction, I think. And this procedure accepts an TAC instruction, a 3-address code instruction, and it sets the result, returns the result, and the result is an assembly instruction, or it can be also a list of assembly instructions. So it just returns a list because a single TAC instruction can be converted to multiple assembly instructions. And since my 3-address code and assembly was the same at the beginning, I just copied the TAC instruction into the result with memcpy and just changed the operands that differ. We want to abstract away from the hardware, so the TAC instruction should be just different from the assembly code. So we want to get rid of this memcpy call, but if I remove it now, it will break the compiler. So basically, if I compile the current stage with the previous stage, I get a bunch of illegal instructions in the resulting assembly. So what we are going to do, we have here a list of if statements, and if each if statements checks the type of the TAC instruction and generates assembly instructions for this type. What we can basically do, we just overwrite the result in such if block, and it probably will fail, but we at least can fix instruction by instruction and not everything at once. In this case, this should work correctly. So here here we reset actually the result. We override it with an RTL instruction, so with assembly add instruction, here too, and here as well. So this instruction should be actually fine. This one as well, since we override the result. let us look exactly. And here, for example, we just use the result from this memcpi set by this memcpi, and we use it here to set the operands on that result. Actually, the result kind is always load word. So what I can actually do is overwrite this result with the new instruction, and we can create one with elna rtl instruction create, and we pass the instruction kind to this function, create load word, and we see what happens. It works, and we do it for the second time here. Basically, each stage of the compiler compiles itself twice, not itself, the previous stage compiles to the next stage, and the next stage compiles itself, and the last stage makes also an additional validation check. It compiles itself and compares the output or the result of the previous compilation with this last compilation, and it was actually pretty reliable as a test that the compiler works. So I could detect a lot of errors in the past, and I wasn't able to break the compiler without noticing it. So it was a good test in the development. Actually, if we overwrite the result here, the compilation fails, so we get invalid instructions. Basically, it's pretty obvious, since we set only the second operand on the instruction, but we don't set the first one. It is the reason why it fails. I think I have a function which can just copy the operand as is. I just have to find it. It will be probably this one. So after we create the instruction, we should just set the first operand. So we call to rtl copy operand, and the first argument is the TAC instruction in the question. The second one is the argument type, it's 1, and rtl instruction is probably the output, I think. Yes, this is the result. And it should be actually enough. Yeah. We don't need this one anymore, since the instruction kind or type is set in the create function. Create basically just allocates the space for an instruction on the heap and sets it type. So we can remove this one. So what do we have here? It is stored. If we look at result, we copy the result into next instruction, and and we are going to look at it later, I think. I just want to check how much we have to do. So basically here all these instructions should be fine, since they just set the result. This one, jump and link, looks a little suspicious. It shouldn't work. So actually I can set the result to the LTL instruction create with the type LTL operator jump and link, and this actually should break the compiler. Jump and link instruction has just one argument, I think. It is the label name it jumps to. So we just can copy this copy instruction from here and just insert it here, and actually I think it should be enough. Oops. So then we have this SGT set greater than. It actually sets the result, I think. So it allocates the operands. It converts the both operands of the input instruction, and we just set result here, so it should be fine. The next one should be rewritten. Result is used here for the first time, and we set next instruction to the result and result to the operands. So basically we should set result to XOR immediate, and if we do this, result is an RTL instruction create, an RTL operator XOR immediate. It should break the compiler because the first argument is not set, the first operand. Yes, and we can copy this thing. I shouldn't scroll the whole time. We can just copy the function name from here and put it in here, and the first argument is TAC instruction. It is the first operand, and the last argument is basically result. And if we do this, then it works. So set greater equals, I think it's pretty the same. Yeah, it's actually the same, so we just copy the result creation and operand copying and try to compile the compiler. Okay, and the other instructions seem to be actually fine. So here we set the result. It's kind of a little different, so we pass here the result as argument, and actually it can just change this value, but it shouldn't. This is an RTL binary equality procedure. Let us see what it does. So it takes this binary result and it sets the second operand on this result, and it sets the next value. How do we use this binary equality procedure? Does it look always the same? I think so. Yeah, it is basically used only for two instructions, for set equal and set not equal. So we actually do not need the result here. We can actually just allocate this result directly in that function. Would be nice to know the type of the instruction. So let us pass it an additional argument. We call it instruction kind. And when we call this function, we pass the instruction kind to this procedure. Exactly. Well, we can try to reset this binary result to a new value with RTL instruction create, and its kind is then the instruction kind. It should break the compiler again, and it does. I hope the binary result isn't used before. No, and we need this copy thing because we need the first argument and probably also set next instruction kind, and it sets it. Yeah, that should be fine. It has only two operands since it sets, I think, the first argument. Yeah. So we just need to copy the first argument from the original instruction into the binary result, and with a little luck it should work. It doesn't. Do we assign binary result? It's binary equality. Yes, we assign it to the result, and we set then the type but it actually we set the next instruction to this binary result. Here's the instruction kind. The instruction set operand. So let me kind first this instruction. So the comparison itself is done here with an XOR instruction. This is the problem if the compiler doesn't have any error checking. I think this will be really the next thing that we do, because the compiler gets bigger and it's difficult to find errors. So I really need to take care at least of basic error checking, so I get some errors about wrong syntax or types or whatever. I think that it will be probably the next thing that I should look at. Type checking would be interesting, because it would help also to implement some features that can be implemented now. Now I don't know anymore what was the result. I think it was kind of successful. Yeah. Basically, now we don't need this binary result anymore, so we can remove this argument and make a local variable of it. And I actually think that we can move this parameter to the second place, and we should adjust the procedure call equality. So basically we don't have this result anymore. We can remove it, and we move also this thing here, and we try to compile it once again. And I strongly believe that we don't need the second line. Okay, what we do have here, then we have these unary operators, so negation and the not operator and jumps and whatnot, and they are not completely implemented, so they just keep their operands of the result I actually think the most of them so not have two arguments. Jump has just one, the label. Branch equal 0 has two operands. Yeah, we write it directly here. So what we are going to do, we are going to create a new instruction, the same as before, and then copy the arguments. It's just a few lines for each instruction, and we begin with this negation. So we just say that result is an arterial instruction create, and the type of the target instruction is just negate itself. It will crash. Negate has two operands, so we won't copy just one argument as before but two. So after creation, we just copy the first argument first, and then the second one, and we can remove the last line, I think. So we check it once again. It looks fine. Then we can copy the same thing here, but we make it to be the node instruction and check that the compiler works. The jump instruction has just one argument or operand, a label. So we first create a new jump instruction and copy the first operand. It still does what it should. Then we have branch equals 0. Let me think. I think it actually has two operands. It is the label to jump to and the condition. So I assume we can make it just one by one. So first we create a new instruction and let it be. This one probably should be changed later. So branch equals 0 is the instruction from the RISC-V. The instruction in the 3-address code should probably be different, but I'm not sure yet what exactly. For example, GCC, or at least generic in GCC, has if-else instruction that basically an instruction which takes a condition and two operands. It jumps to the one label if the condition is true, and to the another label otherwise. Actually, it would be possible for our 3-address code, since our 3-address code has 3 operands, and as said, it would be the condition, the second one would be the if label, and the third one would be the else label. And as I said, we just do it one by one. We remove the last line, and I suppose it should still fail. And if we copy this instruction once again and set the operand to the second one, then it should compile actually. Yeah. So now we have this start instruction. Actually, a lot of 3 address representation that I see in the internet have this start instruction. So basically the first instruction at the beginning of a procedure, but I don't know if this that useful. It can be useful when you generate the assembly. You can save there some data like the stack size for the procedure. So start doesn't have any arguments, I think, so we can just replace it and be done with it. Yeah. What else? Return. I think return is currently, yeah, return should be actually extended, so the current return instruction is just the same as the assembly instruction, so it does nothing. So it does something, it jumps to the previous procedure, but I mean it doesn't accept the return value, but in the assembly, but we can accept a return value in the 3 address code. It would be basically useful, because I think that how it is currently implemented, it relies on a hard-coded temporary variable which is returned from the procedure. We can just extend this instruction to return a value from a procedure. We are going to do it later. Now we just can replace this instruction with the instruction with the same name, without any operands, and it probably will work. And it does. So, and now we have the assignment. This is the last one. And here actually we free the result, so we can be sure that the result isn't used here but recreated. So we can just remove this 3 call and it should be fine. And we have the only remaining instruction somewhere above the middle. It is this star world. Basically we need to replace this result, and we save the result in the next instruction variable. Next instruction is probably not the best name. Basically we return a list of instructions, and the first instruction is the result, and the last instruction in this list is the next result. It is done this way to combine the lists a bit faster, so we always know what was the last instruction in the list. Here we set the kind of the next instruction. If we want to break this, then we can just write that we assign a new value to the next instruction, so it would be basically an RTL instruction create, and the instruction is starward. To be sure that the compile is broken after that, we do the compilation. It works. Unexpected, but fine. I suppose I just reset all operands. So basically here I set the kind once again, then I set the first operand, and then here I set the last operand. Yes, it should work, but we actually don't need this kind anymore since it's set in the create procedure. Yeah. So it looks fine. Okay. It still relies somewhere on the result. So the result remains somewhere unchanged and it still works. We could try to check if all instructions are handled. So we can add an else condition here. And I had somewhere a debugging snippet that I can copy, and in this debug snippet I don't need the first two lines, and here I just want to print something just to see whether this gets executed at all. So we basically generate a comment line in the resultant assembly. Okay, let's compile it. No, it isn't called. Interesting. Somewhere we have a problem. With this result. So this condition checking can be problematic, I think. So we are going to add the same printf in here, and we just write some string, and we flash all streams and try it again and see if it now appears in the resultant assembly code. No, it doesn't. Okay, we are going to move, oops, this was too much, in here. Result, operands, next instruction here. This shouldn't be the problem. This one probably. Still nothing. This one is forgotten. I just overlooked it. So it is not a real instruction, so I mean this one, this is TAC operator label. It is not really an instruction, it's just a label, a declaration, but I didn't find any better way to represent labels in the procedures. For example, these are the go-tos labels, but I think also the others, for example, the if statements automatically generate labels, and loops will later use labels, and we have this instruction that doesn't go directly into assembly. It goes into assembly, but I mean it isn't saved in this text block in the final program in the executable, but it is saved in the symbol table in the executable, and the symbol table points to a position in the source text. Labels take only one argument, so it should be actually pretty simple, I think. To be honest, I want to remove other printf calls. If I didn't, no, I have only this printf. Okay, then we can just say that result is LTL instruction create in the assembly. It has basically the same name, label, and we just copy the first operand, which is the label name, and it should be fine. So let us try once again. We still have set less than instructions. Let us look where they are used. Set less than. For example, here, but it doesn't look that bad, so we just set the result, and another case is here.